Hey, what's going on everybody? In this video, I'm going to solve the question binary subsequence rotation. This is the problem E from the Codeforces round 651. In this question, we have been given two strings, S and T. We have to convert S to T by doing some operations, and we have to minimize those number of operations. So both these strings are binary, and the operation that has been asked to perform is we select a subsequence from the given string S and we rotate it clockwise by 1. So what we can do is, in this example, let's suppose we have been given the string S as this, and we choose a subsequence which is composed of the indices 2, 6 and 7. So we pick 2, this one, the 6th index and the 7th index, and when we rotate it by 1 in the clockwise direction, we are going to get 0, 1, 0. And what we are going to do is we are going to change this in place. So this 1 becomes 0, this 0 becomes 1, and this 0 remains as is. Let me take another example and show you what rotation means. So if we are given a string, suppose this is a string, and after one rotation, we are just going to place this in the first position, so it becomes 0, 1, 0, 1, 0, 1, 0. So this is the string after rotating it by 1 in the clockwise direction. Moving for a while, we can understand that whenever strings S and T have different number of ones and zeros in them, they are definitely going to be non-convertible. Like in this case, the first string S has 5 ones and 6 zeros, 5 ones and 5 zeros, and the string T has 5 ones, 6 ones and 4 zeros. So it's going to give a -1. That is, these are non-convertible. Another observation which is important is, if we remove the places where S and T are equal, then we are going to get that particular sequence of S in which we should do an operation. Since these places, like in this case, these 0 places are equal in S and T both, so we can just forget about these because we shouldn't bother about operating on these places. After all, we are taking a subsequence, so we can take it in such a way that we skip these positions. Coming to an example, let's suppose we have these two strings as S and T. Now the first thing we should do is we should check the number of ones and zeros in each of these strings. We find that these two are equal. The ones in this and the ones in this both are equal. So we can say that the answer is going to be something. It shouldn't be -1. Okay. The second thing we should do is we should remove all the places where S of I and wherever Si is equal to Ti. We'll remove all these places. So removing all these places, we are going to get a string, two strings which are of the form this. Okay. Now the observation that we had seen earlier, whenever we have, let's suppose, now coming to the observation that we had seen earlier, let's suppose type 1 be defined as 1, 0. whenever we find a place where Si is 1 and Ti is 0, we say that the index is of type 1. Similarly, for type 2, it is this. And we saw that whenever we have a string, whenever we have two strings that alternate in type 1 and type 2 indices, we will be able to convert them in one operation. For example, this kind of string. In this kind of string, if this is S and this is T, we are able to rotate this by one position and attain this string. Okay, we have this concept ready. However, we should remember that whenever we after this, what we should do is we should greedily check for how long a string we can make of type 1 type 2 alternating, and we'll use one operation to change that subsequence. So in this case, let's suppose we are taking the subsequence starting from here. So we take this position, this, and this. So we have 1 0 1 0 1 1 0 0 1 and 1 0. But we should remember that both the subsequences should be of even length. If they are of odd length, the number of ones and zeros are not going to be the same in both these subsequences. So for that reason, I am going to just omit this one. Now the remaining subsequences that I have is this. So in this particular subsequence, I can rotate it by in only one operation. So this will take only one operation. Coming to the, after having done this particular operation, now we can come to the rest of the string. So what we have is, we'll take this one, this, and one of this, and we remove it. So first we have removed these particular things. After that we remove this and this. We don't take this because we want the length to be even. So this was the first subsequence that we had taken and rotated. This is the second subsequence that we have taken and rotated. This and this makes the second subsequence. After that, I'm going to take this with this, this and this, and this and this. So in total, we are going to have 5 subsequences which are going to be alternating in type 1 and type 2 configurations. Now coming to the part where we have to implement this, it's a very elegant optimization that is required, because the code should run in less than O of n square. For this, what we should do is, I maintain 2 different banks. One is unstable bank for type 1s and an unstable bank for type 2. In this unstable bank of type 1, I'm going to store all the 1 zeros which have been started but have not ended their subsequences. So let's try and implement it first. I think you'll be better able to understand after that. So I take I just traverse this array. I take the first index and I find a 1 0. Now I don't find any unstable type 2. I don't find any unstable element of type 2. So what I do is I make this unstable. Now I find another unstable of another type 1. So what I do is I start another path from this. Now I take the next element which is of type 2. What I do is first I check, do I have an unstable element of type 1? If I have that, I'm just going to place it over here. So what this does is I have a type 1, type 2 alternating subsequences now. Okay, so I have this. Now after running this for a while, then running the same thing for a while, this gets over here. After this comes this, and because I don't have any unstable structures over here, because whenever we find any element which is of opposite type, I'm going to declare this as stable. So this has become stable. So what I'm going to do is I place 1 0 over here. I can comfortably place a 1 0 over here because I don't have anything unstable in type 2. Then I see the next element, this is 0 1, and I have an unstable of type 1, so I place it over here. Then I see a 0 1 again. I see 3 0 1s occurring, all of type 2s. So what I do is, since I don't have any unstable of type 1, I'm going to make 3 of these. I start 3 paths from these 0 1s. So now I am over here. I have completed this element. Now talking about this will go definitely to the unstable of type 2 because it has to stabilize it. So this is going to stabilize it. Then comes this stabilizes this, and this finally stabilizes this. And what I just want is the number of total paths that I have started. So I started this, and this. So in total number of paths that I have started is equal to 5, and that is going to be my final answer. Now coming to the code for this, what I did is I took 2 elements. I did not maintain a full data structure, I just maintained count of the number of unstable elements that I have. And at any point when I get the maximum, and I also took two integers that updates themselves with the maximum value, maximum length, maximum number of paths that I have started in the unstable of type 1 and type 2. So the number of paths equal to 5. Now this number is the final answer because this corresponds to the number of subsequences that I require to change so that it gets converted to its corresponding value of t. And this is the minimum number because we have taken the optimization of alternating type 1s and type 2s, and we have taken it to the maximum limit it is possible for each of these elements. So for the first index, the maximum possible that I can stretch to a type 1 type 2 alternating configuration is 4. Similarly, like for all these elements. Now coming to the code for this question, what I have is Okay, so here is the input, and I maintain two integers 1 and 0. So whenever I see a type 1 configuration, I store it as a 0, and whenever I see a type 2 configuration, I store it as a 1 in this vector v. And then I have this condition: if I have 1 minus 0, 1 minus 0 equal to 0, then only I can continue. Otherwise, I definitely have either type 2, either the number of type 2 greater than type 1s, or either the type 1s greater than type 2s. So in that case, the number of 1s and 0s won't be same. That's why I'm going to print a -1. Okay, so to clarify it once again, this zer represents the number of type 1s and this 1 represents the number of type 2s. Okay. And in this next line, I maintain two integers, ua and ub. I initialize it with zeros. These are the unstable banks that I have stated over here. These holds the number of paths that I have started in that are activated at the current position of our traversal. This SA and SP are not required here. I have not used it anywhere. After that, I have two more integers, max A and max B. The max A is going to update itself according to UA. It's going to update itself according to UA, and it's going to hold the maximum number of paths that had been started in the first bank, in the unstable bank of type 1. So whenever I see the maximum value of UA, that is going to be the max A, and similarly for max B. So whenever so let's traverse this array V. If we have vi equals to 0, what we have is we have the element is of type 1. So what we see is, do we have any unstable element of type 2? If it is 0, if there is no unstable element of type 2, I'm going to increase UA, because I'm going to place that particular element in the unstable bank of type 1. Otherwise, I'm going to decrement the unstable bank of type 2, because it's going to stabilize this the element of type 2. And similarly, I do that when vi equals to 1, the opposite of that. After that, I have max A and max B, which contains the maximum number of paths that I had ever started, because that is going to represent the number of paths that I actually require, the number of subsequence that I actually require. And so when I sum these up, this is going to be my final answer. Okay, thank you guys for watching this video, and